Hello everyone, my name is Yong Chan Ho. Today I'm going to talk about what is p-value. There is the overview of this tutorial. At first, I will talk about what p-value is and the definition of the p-value. Then I will teach you how to calculate it. After that, I will tell you some misunderstandings of p-value to make sure that you have a clear concept on p-value. Then I will show you 3 examples how to apply the p-value in the hypothesis testing. Finally, I also will give you some exercise to you. First of all, let me introduce you what is p-value. In statistics, the p-value is a function of the observed sample results that is used for testing a statistical hypothesis. Statistical hypothesis is a claim that is shown to be valid by demonstrating the calculation from assuming the null hypothesis to be true. Before performing the test, a threshold value is chosen, called the significance level of the test, traditionally 5% or 1%, and it is denoted as alpha. If the p-value is equal to or smaller than the significance level alpha, it suggests that the observed data are inconsistent with the assumption that the null hypothesis is true, and thus the hypothesis must be rejected, and the alternative hypothesis is accepted as true. When the p-value is calculated correctly, such a test is guaranteed to control the type 1 error rate to be no greater than alpha. Statistical hypothesis tests making use of p-values are commonly used in many fields of science and social science, such as economics, psychology, biology, criminal justice and criminology, and sociology. Then let me talk about the definition of the p-value. The p-value is defined as the probability. It is the probability of obtaining a test statistics as more extreme than the observed test statistics against the null hypothesis, given that it is true. The smaller the p-value, the less we believe in null hypothesis. For whitetail, the p-value is the probability of x greater than or equal to test statistics, or 1 minus the probability of x smaller than or equal to test statistics, if the distribution is symmetric about 0. For left tail, the p-value is the probability of x smaller than or equal to test statistics. For two-tailed test, the p-value is the probability of x greater than or equal to test statistics plus the probability of x smaller than or equal to test statistics, or 2 times the probability of x smaller than or equal to test statistics, if the distribution is metric about 0 2. Then let me talk about how to calculate the p-value in the hypothesis test. Before calculating the p-value, we need to calculate the test statistics. There are some different kinds of test statistics. For z-test with one side, step 1 is that we need to set the hypothesis, that is null hypothesis and alternative hypothesis. Then step 2 is calculate the test statistics z-log, which is equal to x bar minus mu over sigma over root n. After that, step 3 is calculate the p-value, which is equal to the probability of z smaller than z-log. Finally, reject the null hypothesis if p-value smaller than alpha. And the Excel function is norm as dist. In here, U is the population mean of samples, x bar is the sample mean of the sample, and n is the sample size, and alpha is the significance level, and sigma is the population SD of samples. Then for z-test with two sides, Step 1 is also we need to set the hypothesis, and the step 2 is calculate the test statistics Z0. After that, step 3 is calculate the p-value, which is equal to 2 times probability of Z greater than absolute Z0. Finally, reject the null hypothesis if p-value smaller than alpha. We can use Excel function to calculate the p-value, which is 2 times norms as this. There is a graph to show you the p-value region, which is the rejection region for the two-tailed z-test. Then for t-test with one side, step 1 is that we need to set the hypothesis. Then step 2 is calculate the test statistics T0, which is equal to x bar minus mu over s over root n. After that, step 3 is calculate the p-value, which is equal to probability of t n minus 1 smaller than test statistics. Finally, reject the null hypothesis if p-value smaller than alpha. We can use Excel function to calculate it, which is t-dist. There is a graph to show you the p-value region, which is the rejection region of this one-tailed test. Then, for chi-squared test, step 1 is we need to set the hypothesis. Then step 2 is calculate the test statistics chi-square, which is equal to n minus 1 s squared over sigma squared. After that, step 3 is calculate the p-value, which is equal to 2 times probability of chi-square n minus 1 smaller than test statistics. Finally, reject the null hypothesis if p-value smaller than alpha. We can use the Excel function to calculate it, which is 2 times chi-squared dist. There is a graph to show you the p-value region, which is the rejection region for this test. Then, for binomial proportion test, step 1 is that we need to set hypothesis and the alternative hypothesis. Then, step 2 is calculate test statistics Z0, which is equal to p minus p0 over square root of p0 times 1 minus p0 over n. After that, step 3 is calculate p-value, which is equal to 2 times probability z greater than the test statistics. Finally, reject the null hypothesis if p-value is smaller than alpha. There is the summary table of these tests. There are some common misunderstandings that you may think of. The p-value is not the probability that the null hypothesis is true, nor is it the probability that the alternative hypothesis is false. It is not connected to either of them. It is the probability of obtaining a test statistics by assuming null hypothesis is true, so there are no relationship with each other. The significance level alpha is not determined by the p-value. The significance level is designed by the person conducting the experiment. The p-value is not the probability that replicating the experiment would yield the same calculation. The p-value may be changed after you repeat another time of the experiment. Then let me show you 3 examples. The first one is about z-test with one side. There is the solution of example 1. First step is we need to set the hypothesis. Then we calculate the test statistics and p-value with the Excel function. And then we reject the null hypothesis as p-value smaller than alpha. The example 2 is showing you it is about z-test with two sides. Step 1 is that we need to set the hypothesis to. Then step 2 is calculate the test statistics Z0 p-value with Excel function. Finally, do not reject it as p-value greater than alpha. Here is the example 3. It is similar to example 2. It is about t-test with one side. The solution is that step 1 is we set the null hypothesis, and the step 2 is calculate the test statistic and the p-value with Excel function, and we reject the null hypothesis as p-value smaller than alpha. Now there is 2 exercises for you to practice about the p-value. This is the end of the tutorial.